Alright, everybody, we should be live for our next Perceptive podcast here on the channel. I am Josh Beiser, and we have another great discussion for you today. I am joined by returning guest Brian Cronin, who is currently working on the game Monster Train, and we're going to have a little discussion about game programming. We're not going to be going too high level into this one, but we're going to be using this as kind of like an intro level discussion. So, Brian, how are you doing today?
I'm doing well.
It's been a while since we last spoke. How's everything going?
Yeah, I think since we spoke, I moved to Oregon, bought a house, had a child, and have probably worked on 2 or 3 different games. So a lot of activity.
It's been relatively quiet for you, right?
Yeah, sure.
But it's great to have you on. Before we get to our discussion about game programming, like I just mentioned, you are currently working on a game Monster Train. What is that about for the audience watching?
Monster Train is a digital card game that is a roguelike. So if you think of Slay the Spire, which is very popular, it's not unlike that. Some of the main differences are you actually play units down. So it's not just spells. There's spells and units you play, and there's kind of a multi-layer approach to combat. So you play on 3 distinct floors at the same time. There's some other cool differences from that game as well, but that's the basic idea.
Great. So, I know we have just about an hour to spend on the topic, so we'll get right to it. So, for the people watching, what made you kind of suggest wanting to talk about game programming for our cast today?
Yeah, I thought, well, obviously it's something I'm very interested in. I've been doing game programming for about 15 years, professionally, and before that, not professionally. I think it's an interesting topic. Even if you're just interested in playing games, I think understanding how games are created can give you a new level of appreciation. And there's also been a lot of discussions recently on game engines from games. I think Unity has taken... some gamers view Unity as a bad engine or something based on some of the games that have been created or some of the kind of shovelware that's been created. So I want to kind of dispel some of those myths about Unity and how Unity compares to Unreal and what a game engine is and all these sorts of things.
Yeah, and there's something a lot to talk about here, and something tells me we are going to be pushing right at the hour by the time we're done here. So if you are free to come back for a follow-up on this topic, Brian, let me know, because I think we can certainly do a lot with even just 1 or 2 of those things you just mentioned.
Yeah,
so
sure.
The first thing I think to start with, I remember having a discussion with a developer. I think he was working on the game Bit Shifter. This was 3-4 years ago. And he was talking about how much of a hurdle it was him to go from traditional programming to actually programming a video game. And I remember a phrase that he said, that designing or building a game is combining programming and entertainment together. And those 2 things aren't normally associated with each other, hence one of the major hurdles when it comes to building a video game.
Yeah, I could speak to that. Another way to think of it is programming, traditionally just programming, not game programming, is you have input and output. So you think of a command line program in the old days of I'm trying to think of a good example here. You want to zip up a file. You have a file and you want to compress it. You have a program, that file's given the path to the file you want to compress, and out comes the zipped file. So it's kind of just a input output type of thing, and it all runs in one go, and it's done. So that's kind of how programming was originally conceived, and the sort of tasks we were solving in the early days, and continues today. Whereas a game it's an iterative thing. We talk about a game loop. That's one of the core fundamental things to understand about game programming. We are rendering the game every single frame, and we're looping, and the game is responding to the player interactively, and all these things are very much outside of the traditional model of programming.
Yeah. Now, you said a few minutes ago that you've been doing this for about 15 years now. And one of the major things that's happened over the last 10 years, I'm sure you and everyone else can certainly relate to, has been kind of the growth of public game engines and kind of the spread of I guess, the knowledge and accessibility. Again, when I was in high school, that would be late '90s, early thousands. We were just simply using, I think we were using a C sharp at the time, and that was considered it. There's no such thing as Unity, Unreal, anything like that. And then over the last 10, maybe even 14, 15 years, we've seen more this push to make game engines and, by extension, game programming more accessible to people. So, for the people watching us live recorded, what are kind of your thoughts on where, I guess, programming and programming languages or even engines have come in the last since you started doing this?
Sure, yeah. I think it might be useful to kind of break down what is a game engine, and just to do that briefly, it's not really anything that's rigidly defined. There's a lot of people that say they have a game engine, and it's very loose what they have, and that's totally fine. And there's other people, like Unreal or Unity being the best example, have a big monolithic game engine that's a whole tool set, and so it's kind of a loose definition. But a game engine is traditionally something that helps you make a game. So instead of starting from scratch, you have a level editor, you have maybe some kind of built-in animation tool. It's a set of tools, and usually an interface to program within those tools to make a game happen. So when I was starting out, there was definitely some game engine-like things. I think Unity was really early on. Maybe didn't exist when I first started, but within the first few years. I was using a tool called Ogre 3D to make my first indie game, which is not necessarily a game engine, but it's a rendering library. So it helps you display 3D graphics on the screen. So my first game engine that I made was, again, very loose definition of an engine, but it was a series of these open source libraries. We call them libraries when you're programming. A library is just a kind of a tool you can import into your programming environment, and it helps you do something. So I had a library to render graphics. I had a library to simulate physics. I had a series of these libraries that I kind of cobbled together, and I had a few of my own tools, and that was my game engine. So there's still a lot of benefits to having your own game engine. There's a good amount of indie devs, for example, that have their own game engine. There's a lot of big AAA studios like Ubisoft and whatnot that have their own internal private engine. And some of those advantages are you have full control of everything. So, if there's a bug in the Unity engine and maybe we don't have full source access to that engine, we have to just go with the customer support, basically, to try and solve that bug. Whereas if you have your own engine, you can just fix that bug. There's, of course, downsides to having your own engine as well. You have to build it all yourself. But that's I don't know if that maybe very broadly answers your question, but we could expand on that.
Yeah, and for those of you who remember, we saw that whole expose from BioWare with kind of the downfall of Anthem. One of the things that was kind of cited in that was that they were forced to switch to, I think it was EA's engine. That was the Frostbite engine. That they had no real understanding, or they didn't really know too much about it. And it can lead to a lot of these problems. Because as you said, the engine itself is its own self-contained toolbox. If you build your own, or if you're well acquainted with it, you can basically do whatever the hell you want with it. But if you're trying to use somebody else's engine, it's pretty much almost akin to trying to learn another language, or read an instruction manual that's in a completely different language, and
Or another way to think of it is if you're used to Photoshop, then all of a sudden you have to use Illustrator or some other photo editing application. You understand the basic language of the thing. You know that you need to, color pixels in that example maybe, or crop, and etc. But how exactly you do it is slightly different, and that requires learning.
And I just had to do some photoshopping right before this cast. So you're hitting a little close to home with that one, Brian.
Yeah.
But as you said earlier, with the distinction between building your own engine and using somebody else's, this, of course, has led to the whole, Unity discussion, especially among consumers versus developers. And it's become a popular pastime among consumers and YouTubers to instantly decry anything that shows, made in Unity as shovelware, trash. Shark probably has, like our quote bingo right now. Developers are lazy, and how dare they use Unity and stuff like that. So, as a programmer, what are your thoughts on Unity as an engine or Unity as an option for game dev?
Yeah, I tend to be a very pragmatic programmer, so I view it as there's upsides and downsides. One of the upsides of Unity is it's very quick to jump into, and my screen just turned off because I went to sleep. Anyway, I'm back. Yeah, so it's very easy to jump into, and I think that's part of the reason why you do see a good amount of, for lack of a better word, let's continue using the term shovelware on Steam, for example. There's a lot of call them asset flips, like people downloading stuff from the asset store and mixing it up a bit and releasing it as a game. That kind of thing certainly happens. That speaks to the accessibility of Unity. And that's ultimately a good thing. It's good that more people can learn how to make games. I was working with a middle schooler who's trying to learn how to make games. He's probably in 7th or 8th grade at this point. And we're just emailing, and he's working within Unity because it's accessible. It's free. There's a lot of tutorials. That's all good stuff. Yeah. But it also leads to what's largely just a perception problem, because there's also a lot of very popular games that are have no frame rate issues, no bugs, whatever. I shouldn't say no bugs, but a few bugs that are made in Unity. And so it's a tool, and just like any tool, it depends how you use it. And you can make an equally bad game in any game engine. That's really a small part of the formula.
Yeah. And I remember when I was at one of my library presentations, and there was this family of 3, and the father, daughter, and son were all trying to make a game together. I forget what they were using. I think they were building it in Minecraft or Roblox or something like that. But all 3 of them were basically trying to make a game as a family, which I thought was really nice.
Yeah, there's plenty of other tools too. There's Scratch is one that is a very simple programming model that's all visual. You just drag blocks around to program. So there's all sorts of tools. So yeah, Unity is accessible. It's very popular. One of the things, so I work primarily on Unity, and one of the things I like about working in Unity is if I have a problem, I can do a Google search and I can find the answer usually within minutes. That's just because so many people use Unity and so many people have encountered whatever problem I'm going to encounter. So that's one of the advantages of working within a very popular game engine.
Mm-hmm. So I guess as for new people watching this right now, either live or record, especially on the younger side, would you say that Unity is a really strong engine? What would you be considered be entry level, kind of somebody who's never done game programming, who maybe has either little to no experience of regular programming? What would you consider? What would be your advice as a good entry point?
Yeah, that's a good question. I guess it partly would depend how technical this person is and if they're even interested in programming, because there's all sorts of ways to make games that don't even require programming. So if they were interested in programming, they were a little bit more technical minded, and they really wanted to make, let's say, a more traditional style of video game, I would certainly suggest Unity as a good starting place, mainly because you can use that tool to make pretty much any game you want. And there's a lot of tutorials and ways to learn Unity. If someone was, I'm trying to remember the name of this tool. There's a tool where you can just make visual novels.
I think it was Twine.
Yeah, I'm thinking of Twine. So if someone was more interested in maybe doing interactive fiction, I would suggest Twine. So there's a lot of different answers. Game Maker is another one I've heard is quite good for someone first learning, but I don't know. I don't use Game Maker myself. So yeah, it's a question that it would very much depend on the specific person asking, I think.
Yeah. And I think bringing this back to Unity, that as you said, we have seen some amazing games built off of Unity. The go-to example I always bring up, of course, is Hollow Knight. I mean, that game is just so damn impressive. But as you said, I have also seen plenty of asset flips. Shark, if you're still watching this, I think he can probably of a drinking game. As many times we've had a acid flip game that was submitted for one of our indie spotlights, or we saw it when we look at some of the upcoming games. And there are a lot of people. I haven't heard this as much lately, but like a year, maybe 2 to 3 years ago, I saw people saying, if this game is Unity, then no sale. I don't want to play it at all. And I always found those discussions to be just very weird.
Yeah, it would. To me, what that sounds like is, let's say you're buying a new kitchen table, and you have a specific kitchen table you want. You want it to be red. You want it to have 4 legs. You want it to be 5 feet across, etc. So you start look at tables, and most people would just be like, "Oh, this is the table I want. It's red, has 4 legs, etc." And then you have this strange customer that comes in and says, "What type of hammer did you use to make this table? Was it this specific hammer that I like, or was it this other hammer I don't like?" That's important to me, and I'm not going to buy your table unless it was the hammer I like. So it's kind of an arbitrary thing that, from my perspective as a game developer, there's good games and bad games, and that's a huge spectrum. There's games that I don't like that are generally considered to be good, and there's buggy games and whatever. But I don't think you should put a value statement on the tools they're using to make that game, as much as you should just evaluate the game itself.
Yeah. And we've been kind of talking a little bit about finding bugs and optimization. I do want to spend some minutes on that topic. But before we get to that, again, for new people, especially students watching us either live or record right now, I want to spend at least a few minutes talking about the idea of building your own game engine. Because this is another thing I think, it sounds like, this is another one of those aspects that sounds like it can be very mysterious or very daunting, especially, again, if you don't already have a programming background. For regular watchers or listeners right now, we did do a cast with, I think it was Tim Baudet. I think he was building his own game engine, and we were talking to him about some of the challenges and stuff. But I want to get your thoughts on this as well, Brian. So,
sure.
For somebody watching us right now, why should they consider building their own game engine, and what would be some things that would maybe dissuade them from doing so, and instead focus on using a commercially or public grade engine?
Sure. Maybe it would make sense. Could I drop into screen sharing at this point?
Sure, go for it.
Let's see if I can go ahead and do that. So you should see some code on the screen.
Yeah. Okay.
So this is just some code I downloaded. Let me switch over to the project. This is just a Unity sample project. And let me just demonstrate. It's just a simple platformer. You can run around, you can jump, you can collect crystals, and you can, like that. But just to give you an idea, that's what this sample project is. This is something I just downloaded. Unity has as like a learning tool. Okay. So there's all sorts of things in here I'm not going to try to cover right now, but this is a game engine. This is Unity. I have the game in the middle. I have like different views into the game, et cetera, et cetera. And this provides all sorts of things that help me get started on the game. So, for example, I'm not going to go into great detail on this code. So if you don't know how to program, don't worry. I'm just using this to demonstrate a point, and it will answer the question you're asking. So, for example, here is an audio clip. So this represents the jump sound, jump audio.
You may want to zoom in just a little bit. It's kind of a little bit hard to see the actual text itself.
Sure, that'll be better.
Yeah, that's good.
Great. So yeah, this is an audio clip. So this is the jump sound, the respawn sound, getting hurt, ouch sound. So we have some audio clips here. We have some kind of like speed values, jump speeds, all sorts of stuff like that. What else do we have here? Sprite Renderer. So this is what's actually, let me go back to the game. This little character here, the blue character, we call that a sprite. That's just I don't know where that term originally comes from, but it's really just a image on the screen as a sprite. It's usually a 2D image on the screen. Anyway, so I have the ability to access that sprite, maybe change its animation. There's animation here. This is a piece of code that will allow me to animate that sprite, some physics values, et cetera, et cetera, et cetera. So this keeps going on and on and on. So the advantage of using a tool like Unity is, here's that Sprite Renderer, for example, on the screen. It's a little bit small. It has all this ready to go. So I've done game jams where I did one in January where I just show up And within half an hour, I have a basic game up and running. I have the sprites on the screen. I could have sound effects. Characters are moving around. All that stuff you could have up and running very, very quickly. In the matter of minutes or hours, you could have something working. So to contrast, if I was creating my own game engine, I would have to start at the very basics. So this whole thing of just a nice little package here of me being able to render a sprite on the screen, I would have to spend probably, I don't know, dozens of hours to get that to work. So, that's kind of, in terms of dissuading people, that would be one reason not to create your own game engine is it's going to be a lot of effort just to get your game up and running. Now, one reason to write your own game engine is if you want to learn how to write your own game engine. So if you're not as interested in making a game, but you're more interested in kind of the craft of programming and game programming, I think working on your own game engine is a great thing to do, just as a learning exercise. And how does this sprite renderer work? That's something you're going to be able to answer if you dig into the details and make it yourself. A second good reason to write your own game engine is if you're doing something very, very unique. So, for example, like the original Minecraft game was doing something that not a lot of other games were doing, and a world that is limitless and you could dig into however you want, all these kinds of things. You could certainly make a game like that within Unity, and now more so that a game like Minecraft is super popular. There's all sorts of tools to help you with that. But if you have some other kind of unique game idea that is going to be technically very demanding, that could be a good reason to start writing your own, technology to support that.
And Shark asked us in chat, I think this would be an interesting point, because one of the things we were talking about, especially when we were discussing platforming and platforming design, is the difference between simulated physics and using a physics engine. And for this kind of, with Unity and what you're seeing here, what kind of physics would be, I guess, on display here?
Sure. Yeah, so this right here is just kind of not using realistic physics. Like if you think about it, no human can jump that high, and it's very floaty and kind of weird. But it's doing its own thing, and that might be right for this game, but it doesn't react like real life. And it's 2D, so I mean you can have 2D physics, but our physics in real life is 3D physics. So pretty much any physics engine is not going to be super realistic, especially when you first start using it. I did a physically simulated game a long time ago that was go-karts, and so we used a physics engine to simulate all those collisions and reactions of when the go-karts slam into each other. So if you're making a game that really depends on realistic physics, starting with a physics engine is a good bet, because you're going to get all those reactions the way you expect. But most games, especially platformers, you're not going to want to use a proper physics engine. You're definitely going to need collision detection, and the collision detection is kind of separate but related to physics simulation. But so this little sample game, it right here is kind of where it does most of its physics. And so it's using the concept of velocity, and I don't know how many people took physics in school, but velocity is kind of a measure of your speed over time. So it's how much you're going to move over a given time frame. So you can see things here like it's taking into effect gravity, and this operates over time. So it's using time here in this calculation. But this is not super complicated stuff here. I could go line by line and explain it, but basically it's just based on your movement. So if we go into this code, we can see here this is where it's getting the input. So it has a move variable. So move along the x-axis is your horizontal movement. So this is when you press the left and right arrows. And then it has a jump button it detects. And it's this is where it's probably queuing up the sound to jump, etc. And then inside this code, it's using those values to actually move the character. So perform movement. So this is kind of the physics here. This is the physics of this game is pretty much all within this little chunk of code. And down here as well. So it's not super complicated, and it's not using real physics kind of quotes around that. But this is better for this sort of game where you want to have tight control over how the game feels. Maybe we want the character to actually fall down a little faster than would happen with a traditional physics engine, but we have full control over that, so we can do whatever we want here. And you see this a lot in player controllers specifically. A lot of games that even use fully simulated physics will kind of take control of the player and not place the player within that larger physics world. It's more this tightly controlled thing, because you expect in a first-person shooter to be able to turn on a dime and be able to start and stop instantly, but you can't do that in real life. It takes time to stop and time to get going, and this would all feel really bad in a video game, so we don't do that in a physics engine.
Yep. And as you said, like from a platforming standpoint, we could spend like an hour just about platforming design. That you want the player to know that when they hit the jump button, that it works the same way every time. And if you don't have that, it becomes impossible to build any kind of technical challenge.
Yeah, consistency is important, and you don't want, with a physics engine, there's all sorts of weird little things that'll happen. You'll get these weird collision intersections, like when I jump on this guy, I might get stuck inside the little red blob. That type of thing will happen with physics engines, and you just spend hours and hours to fix these little issues that come up with a physics engine. Yeah.
All right. As a quick time check, we have just about 30 minutes, give or take, for the cast. So, and then also, for anybody watching us live right now, if you have any questions on the programming side about things, please get them in. Like I said, we're going to be trying to wrap this up right around 4 p.m. EST or EDT for Brian. Let's see. Yep. Right. So, before we get to talking more about bugs and optimization, are there any other topics that you want to touch on in terms of general game programming?
I think those two will cover a lot of time. And I'm certainly interested in explaining why bugs happen and why some bugs are very difficult to fix, and just explore topics like that. Right now I'm spending most of my time fixing bugs for our game that is about to release in a few months, and so that's been on my mind. And I actually enjoy fixing bugs, which I think is pretty odd for most game programmers. Will not say that, but I enjoy the process, so I'm happy to try and explain it.
Trying to think if there's anything else that comes to mind. I mean, we could certainly.
Yeah, I mean, we could just talk about the basic, structure, like what is code? What is all this on my screen right now? And I'm not to try and explain it all, but just to. I mean, I'm sure a lot of people have seen code, but how does it work? What's going on here? Just the basics might be worth talking about.
Okay.
So let me just lower this a little bit because it's very hard for me to comprehend when it's so big. Usually I have it way tiny. So there's a bunch of code in this game, and I haven't fully explored this code. I didn't write this code. I just downloaded it. So we can see it's kind of structured. There's a bunch of different folders here. There's some code for the UI, but we'll mostly just stick within this mechanics here. So this is C# is the programming language here. C is an old programming language from the 70s, and there's a bunch of programming languages that kind of derive off of C. So it's kind of like how so many languages are derived off Latin. C would kind of be the Latin to C#, which might be, I don't know, English or something. So the basic structure here is at the very top, you see these statements here. I'm saying using blah, blah, blah. These are kind of like, I used the term libraries before, but I'm kind of importing, let's just call them libraries for now, these libraries. So I'm bringing in the Unity engine. So I'll have access to all the code within the Unity engine. And then they have some platformer code here that I'm bringing in. So I have access to all that code. So, a lot of programming language, you'll see this type of thing at the start, which is just allowing you to access other pieces of code or libraries.
Yeah.
And then most game programming especially is what's called object-oriented programming, and that's just to put a term out there. I won't try to explain that. But what this code represents, we can kind of see there's a structure to it. So code always has a structure. We could see this is kind of a name at the top. So this is the player controller. So it's going to represent actually controlling the player. Pretty self-explanatory. And then we see this bracket, and a bunch of code is kind of wrapped up inside of this bracket. This just keeps going on and on and on all the way to the bottom here. So all this code here represents the player code. And you have a question?
Yeah, just to interrupt for a second, what kind of language are you using right now for people watching?
Yeah, so this is called C#.
Okay.
And it's an object-oriented programming language. It uses something called garbage collection, which is a great challenge. It's another tool that has its upsides and downsides, but that's a whole other thing to jump into. And it's a somewhat modern programming. I think C# ended up becoming popular maybe in the early 2010s, I would guess. And Unity has always used it. You could also use a form of JavaScript with Unity, but most people use C#. So I'll finish this thought up. But I guess what I'm trying to get across is showing the structure of this code is what's important here. Mm-hmm. And we have what we call these variables. This is the audio clip I explained earlier that allows me to play a sound. And we can even go back to the code here, and we see the player controller right here. So this piece of code, player controller, is also represented visually on my screen right here. I'm sorry this is a little bit small. I don't think I could zoom this in. But what's cool about this is I can also increase the player speed right here. So now the player's moving way faster off that cliff.
And all the variables over there that under the player controller script, those are the things that were programmed or those sections in the code.
Yeah, exactly. So we can see this max speed value right here is set to 7 in code, but I can change it to 1, and now we're in slow motion mode. That's affecting this value right here. So that's another cool thing about Unity and using a game engine is this is not something you just get for free with programming. This is something that people built, and we could take advantage of. So that's the basic structure here. This is the player object, so it's a little character on screen here, and it has all these pieces of code attached to it. Here we could see the Sprite Renderer. Again, I explained the sprite is this image, and we can see it's changing the frames. So it's switching between a bunch of different idle frames, which explains why the character looks like it's moving around. That's just like an old flipbook style animation happening right now.
Yeah.
We could go into more detail, but I think that's the basic idea I wanted to cover here.
Yeah, and again, this is we're not going to be going over the entirety of game programming in an hour. No. That is not happening. We may be good at talking about game design, but we're not that good.
Yeah, I thought it would be good just to give people the basics of what's going on here. So you can look at this piece of code, and this is. It is understandable. If any just average intelligence person looked at this, this file is about 140 lines of code. I think most people could look at this, and with an open mind, they could kind of tell me what's going on. Even if they have known nothing about programming, programming languages are actually friendly enough. It's not like a language like knowing Spanish or French. You can, anybody that knows English can kind of look at this and probably determine what this line of code does. Input, get axis horizontal, move X. This is probably related to pressing a button and moving the character. Yeah. Most people will be able to figure that out.
Hundi asked in chat, they were curious about how are game mechanics constructed. They understood the idea of uploading files and programming code,
right.
But how do you create game mechanics? And that sounds like it could either be a very short or a very long answer. I'm not sure.
First of all, I love that question. I think that's such a great question, and that's the core of what I love doing on games. So another idea I wanted to get across today, if we had time, was the idea of game architecture. And that's the idea that there's all sorts of ways to architect how your game functions. And I'm speaking mostly in terms of programming rather than the architecture of the game design. But that has huge influence on what sort of mechanics you could support and how many bugs you're going to get as a result and all these sorts of things. So really, there's no fixed way. If I have a mechanic I want to implement, let's say double jumping, there's a lot of different ways to go about that. Or if I have items is a great example. I have an inventory, these types of things. There's a million different ways I can implement that. And that's where it kind of turns into a soft science where it's up to the intuition of the programmer. Maybe teams are making these decisions together, and there's all sorts of implications of how you structure that architecture to support that mechanic. Because, as we know, as we're making games, They rarely, like, you don't have a game design document in the first day and then you just do exactly what that says to make your game. Your game is always shifting under you, and I've learned that lesson plenty of times. So having that flexible architecture in place will allow you to support those mechanics.
Yeah. And then there's, of course, and I think this is a good segue talking about bugs and optimization, that if your first version doesn't work, or if, let's say, people have a better idea, you have to go in and change that. And when you're altering or changing things, that can lead to these bugs. But I think this is a good point to talk about bugs. So as you said, this could be a cast in of itself, just talking about bug squashing and optimization. So,
yeah,
for people listening, we've used the term, quote unquote, bugs a lot. And for people listening to us right now, when we talk about bugs in a game, what does that mean, like, from a layman's perspective?
Okay, yeah. So a bug is basically a problem. It's some unintended thing happening in code. Sometimes it'll cause the game to crash. Sometimes it'll cause the game to do something unexpected. Let's introduce a bug into this game. Let's just change that X to a Y. So we can see all I did here, I just changed the X to a Y. And that's a very simple mistake you can make, right? That's just one character difference. X and Y don't seem that different, and I'm often using X and Y in this sort of code. So let's introduce that bug and let's see what happens. I haven't tried this ahead of time, so I don't know exactly. I think I know what's going to happen, but I'm not exactly sure. So I'm just waiting for the game to compile, and then we'll run it. And let me press left and right. Oh, okay. So in this example, I'm pressing left and right, and nothing is happening, which is certainly wrong. I thought the character would go up and down, to be honest. I think gravity's keeping us planted. But that's a bug, So that's an example of, that's a very simple bug. I'd be able to figure this out. I can look at, oh, it needs to be X, and now the game's working. Most bugs are not that simple. They're, caused by just interaction of things, usually. You have one good example of a bug that comes up a lot is, like, why do games crash? Probably upper 90% of the time, why a game crashes is because there's, I'm trying to figure out how to explain this sufficiently. There's a reference to something that is missing. So an example here would be, let's try and just do this. So I have an animator here, right? And this is what's causing the character to animate. And I put these two lines in front. That is a comment. So just, that's as if the line didn't exist. So I'm just going to delete the line there. And let's see what happens. Again, I tried this ahead of time, so I think I know what's going to happen. But yeah, okay, so here's a bug. We can see the character is now floating in the air. I can kind of move. Look, I'm going just back and forth. Clearly a bug. I can't move around. And we see at the bottom of the screen, there's all these errors that are being generated here. So we can go look at the error. It's in playercontroller.cs 126. So let's go over to line 126 here. And we see here, this is exactly what I'm talking about. So it's using that animator to do something. It's just telling the animator, I am grounded right now. I'm on the ground. But what's happening is this animator doesn't exist. It's as if it's not here. And it's not here because I deleted that line of code, right? So this is a very common bug in games. And luckily with Unity, it didn't actually crash. I mean, it did something very unexpected, but we got this nice error message at the bottom of the screen. If I had my own custom engine and I had not set this up properly, the program would just close and I'd be back at Windows not knowing what happened. But the nice thing about Unity is it does give you a nice error message and helps you figure out what went wrong. But this is the source of many, many crashes, especially in games, or many, many bugs in any game, is exactly this sort of problem. And the reason why this animator wouldn't be, let's say, connected up properly is it could be so many different reasons. It's probably not something as simple as this, although it could be. But there's all sorts of reasons why this connection might not have been made. That's a classic example of a bug.
And of course, as you said earlier, I remember when I was doing programming in high school, you accidentally type one letter off. Or yeah. I remember, I think we were using C++. If you don't end every sentence with, I think it was a semicolon.
There you go, right there. Yeah, here's the semicolon problem. If I don't have a semicolon there and I save it, I'll get an error message here on the screen, and there's an error message. Oh, I need a semicolon. That's definitely a classic. That one's easy to fix, luckily.
Yeah. And like we've said, like for like the more complicated your game is, obviously it's going to compound the complexity of what bugs can show up, especially if we go from 2D to 3D games. Because as we said, like with 3D, you have a much greater like collision engine, or collision detection, hitboxes, things like that, and there can be so many weird things that can happen. Like for people who've seen like 3D games, or like a character will all of a sudden like their arms or their legs will like spaz out of control,
Right.
and like it looks like a Looney Tunes cartoon come to life.
Yeah, another good example with this happens a lot in 3D games. It can happen in 2D games as well, but in 3D games, some of the 3D games I've worked on, going through the world is a very common problem.
Mm-hmm.
So that happens for all sorts of reasons too. I wish it was as easy to say, oh, if that happens, then
Just
we
do
know it's
this.
a problem with this thing. Yeah, but it's usually not as simple. Sometimes just the way you're moving the player around. Maybe you have a dash ability, and maybe you didn't test that dash ability when the player's next to a wall. And when they dash through the wall because you're not checking for collision when dashing. That type of thing is what leads to problems like that.
And then again, getting back to I think Hundry's point from earlier, like that's when we start getting to that combination of game mechanics and game programming, because you never know, like when you're thinking about a game, how it's exactly going to work to code, and this can lead to a lot of. Sometimes it can lead to very interesting thoughts or new elements in your game, or it could lead to bugs and issues that you didn't even realize could be an issue until you try to put it in.
I think a good example of what I wanted to get across in terms of game architecture and how that affects things like mechanics and bugs is if you think of a game like Starcraft. Most people are familiar with Starcraft on this channel, I imagine. That's a game where you have sometimes, usually dozens, if not hundreds of units all within the world, moving around, doing their own thing. And the player expects to be able to move those around, control them very quickly, with no lag, all these sorts of things. And now it turns out that, I guess I can't speak for StarCraft in particular, but I know that most real-time strategy games, the way they're architected is, you couldn't possibly, especially in the, let's say, late 90s and early 2000s, send all those characters across the network, across the internet to your friend playing on the other side of the country fast enough in order to play that game. Just there's too much going on, and there's too many characters moving around. There's not the bandwidth to do that. You don't have the ability. So the way those games are architected is really clever. They just send all the button presses over the network. So what that means is if I click on a unit and tell it to move to this position in the world, all I'm doing is I'm not sending that character moving through the world. I'm not sending the position of that character moving through the world every single frame. I'm sending those commands that I want this character to move here. And then what happens is the game is designed, it's architected so that it's fully, we use the word deterministic. So what happens on my computer is going to happen on your computer. There's no randomness in there. It's all just going to happen the same. And that's to give you an idea of architecture as I speak about it. That's what I mean. Like the way that you architect a real-time strategy game is very different from a first-person shooter, which has different requirements and usually don't have as many characters. And it's a very different type of game, and how you architect it has huge implications. And so if you start architecting a first-person shooter like you would a real-time strategy game, you're going to run into huge problems that you maybe didn't anticipate at the start.
Yeah, and as you said, like the netcode is a very big deal, because figuring out the netcode for a game like StarCraft is completely different than figuring out the netcode for something like Mortal Kombat or Street Fighter or any kind of fighting-based game.
Yes, sorry, I disconnected on accident.
That's all right.
Yes, netcode is something I've done a good amount. I've made two games that were multiplayer. One was that go-kart game, then I worked on a game called Natural Selection 2, which is a first-person shooter that was networked. Mm-hmm. And networking a game, I mean, that's another topic you can easily spend hours talking about, but it makes the game massively more complicated to have it synchronized over multiple computers. It's really the way to think of it is not that you have one game, you now have, how many players you have playing? 16? You have now 16 games that all you have that one game playing over 16 different computers. It has to be perfectly synchronized, and over different, you have someone in Iceland playing, someone in California. It's a total nightmare. It's a total nightmare.
And there you go. That's our description for game programming. It's a total nightmare, people.
No, not game. But network programming is, it's maybe you have a very, very simple game that doesn't have huge requirements. So most networked games are massively complicated to work on.
And time check, we have about 8 minutes to 4. Do you have time to push a little bit past that, or do you have to get going right at 4?
I probably should get going around 4.
Okay.
Yeah.
In that case, this will be final call for questions from the chat. And for our final topic then tonight, I just want to spend, or for today, just a few minutes on what optimization means. And again, we could spend hours talking about this. So I'm just going to throw it to you right away. So what does optimization mean when it comes to game programming?
Yeah. So optimization just means make the game run faster. Most people would experience this. There's a few ways it can manifest itself a problem, but usually it's low frame rate. So when we use the term render, when we render the game, we make the game appear on your screen. Inside the computer, it's just data. It's just, at the base level, it's bits, and then we represent shapes with those bits that then appear on your screen. So we want the game to run ideally at somewhere around 60 frames per second. So if you think of it a flip book, you're going to see the computer is going to change what's on the display 60 times a second. A lot of console games be 30 times a second. What's most important is consistency, actually. You could have a game that runs 500 frames per second, and then every 100th frame, you get a slowdown where it goes to 5 frames per second. That's going to be way worse than a game that runs consistently at 30 frames per second. You'll perceive it as being a lot better than a game that's kind of stuttery. Yeah. Anyway, so optimization is usually you're focused on getting your game to run at a consistent, ideally fast frame rate. And there's, again, all sorts of reasons why your game is maybe not running at a great frame rate. Some of these, especially in Unity, will be related to garbage collection, which is a topic we probably won't get into too much, but that's one example. There could be that you're, playing too many sound effects all at once. Maybe there's too many physics objects operating in the world at once. There's infinite reasons why your game might be running slowly. And there's many tools to help you figure out why your game is running slowly. And usually that comes down to figuring out, like I showed the structure of code before. Let me just kind of go back into that quickly. So you should see code again. So I didn't explain this, but this is called a function, or a method is sometimes called. This is, code is running here. The things are happening. And this is happening. This is called update. This is happening in every single frame. This code is running every single frame. This is related to input, right? Mm-hmm. So if I'm doing something in here that is slow, code in general, it's kind of like, it's a list of instructions. And so if something in here is slow, any code that needs to happen after this is going to have to wait. And so if you think about it, if I'm doing 60 frames per second, I think it comes out to 16 milliseconds that I need to render every single frame in order to hit that budget of 60 frames per second. So I only have 16 milliseconds to do all the work I need to do to get your input, move characters around, do collision, all this kind of stuff to deliver that game. I have that fixed budget. And if something in here is taking 10 milliseconds for whatever reason, I only have 6 milliseconds for the whole rest of the game to do whatever it's going to do. So I would figure out what's wrong in this, how to speed it up. That's, again, a lot of different ways to do that, depending on what the problem is, but that's to give you an idea of why games get slow and how we optimize them.
Yeah. And I think what you said was very important, is we've played games like this. We've played titles that are like, the graphics are like nowhere near like super detailed, super complex, and these games were slowing down dramatically. Just as we could play a game like Doom 2016, Dark Souls, or anything that's like incredibly like well detailed, well refined graphics, and get zero slowdown, or like very, very rarely.
Yeah, and that's because they've worked like hell to make it work that way. It's probably some number of programmers spent some number of months making the game operate smoothly. So that's always what it comes down to. And any game you make, I'm working on a game myself, just kind of on my free time, and it's the simplest game right now, and it's operating way too slow. So I'm gonna have to spend a good amount of time optimizing it. And it's a dead simple game right now, but it's still just way too slow. So that's just the nature of it. Is you can try and write the game to be as optimized as you can from the start, but you're always gonna have to do more optimization. Another point I'd like to get across on optimization is, this is another thing where games are unique. You have two processors you're running on, right? You have the GPU and the CPU. So the CPU, the central processing unit, every computer has that, and then the graphics processing unit. Those are two independent machines, basically, you're running your game on. And sometimes your game code is running perfectly fine, and you have no slowdown there. But your shaders, for example, on the GPU, there's some slowdown there, and they're working together. So if there's slowdown on the GPU, the CPU has to wait. Or if they're slowdown on the CPU, the GPU has to wait. So those are two forms of optimization, and usually you're just you'll solve one problem, and then it's like whack-a-mole. You have another problem over here you need to solve. There's always a bottleneck in the pipeline, is one way to think of it.
Yeah. We have a few questions in chat that hopefully we can get through before you have to get going, Brian.
Let's go for it.
So let me pull these up really fast. All right. Okay, Thorn asked, is there any particular Unity concept or class that would help out newbies that they likely don't know?
Nothing in particular. I would just, if you really want to jump into Unity, I would certainly recommend starting very, very simple, probably simpler than you want. Like recreating a game like Tetris, I think would be... That's ambitious, I would say. Like, you can probably do it, but it's going to take you a good amount of time if you're starting from nothing, But don't go into it thinking I'm going to make Fortnite, that something like that is probably too complicated. And I think you'll learn faster and better if you start simpler. And also, I think it would benefit you to start with a tutorial. I don't have one I can link to at the moment, but there's plenty of them out there. I think Unity has a bunch. If you just look for a game genre you're interested in, so maybe platforming. That platforming demo I showed is something Unity offers, and there's a whole tutorial that you could follow that I didn't have on the screen that has you go through and make changes to it. I think something like that's going to be the fastest way to learn.
Okay. Malwinius asks, how much does the chosen language matter for the type of game you would want to develop?
It's a really good question. I would say not too much. It's going to, so with Unity, you only have a few options of languages that you can use. So it's going to be difficult to use a language that is not supported by Unity. There might be some way to do it, but it's going to be more complicated. But there's people making games in almost every language. I know Python's a popular programming language, and there's ways to make games in Python. And so if someone was already familiar with a language like Python, and I would recommend they start there. They just... there's plenty of tools within any language. But I'd say the language itself, these programming languages are just tools. I use probably 3 or 4 programming languages regularly. I've used maybe a dozen throughout my career. They're just tools. I'm not too passionate about any language in particular. And I think you can make a game in any programming language probably.
Okay. And final question from Christian asks, can you speak on what tools you use to find those performance hits, specifically in Unity? How would you go about finding the slowdown? Yeah,
let me see if I can remember where it is in Unity. I can maybe bring it up. I'm just kind of looking. There's basically tools in Unity that help you with this. I don't think I'm going to be able to find it at the moment. But let me show you this one thing. Let me go back into screen sharing. So this is a good example. Again, sorry, it's kind of small, but this is there's like this stats display here, statistics. So this shows me some basic statistics. Like the game is currently running at about 80 frames per second. I can see I'm getting 12 to 13 milliseconds per frame. That's where I said if I was at 60 frames per second, it'd be at about 16 milliseconds per frame. Again, you have 1,000 milliseconds in a second to give you an idea there. And this is giving me some basic information about graphics, like how much memory I'm using on the GPU, how many triangles I'm displaying. And this is all happening in real time. So as I'm moving around, as new characters come on the screen, this will all update. I can see I'm actually getting 170 frames per second now. I don't know what changed. I just started moving around. Oh yeah, this is great, right? So right now I'm getting 70, 80 frames per second. If I start moving, I'm getting 185 frames per second. I don't know why that is, but that's showing me for some reason there's something going on where when I stop moving, frame rate tanks, relatively so. But there's tools, and there's definitely a tool within here that I don't know where it is right now. I haven't optimized in Unity recently. That will show me, like, sometimes down to lines of code. Where is your bottleneck? Like, what code is taking up most of your time? So that's called a profiler. So we profile our code. There's also GPU profilers. So there's like great tools that you can, it'll like, you could capture a frame basically, and it will show you everything, all the steps that went into generating that frame. So if I were to generate this frame right here, right, it would show me these backgrounds being rendered after the character's rendered, after these trees. It would show each step, and it would show me at each step how much time did it take to render this building, this character. So there's a lot of tools like that within Unity and even outside of Unity that help you determine where the slowdown is.
All right. And again, there's still so much more we could certainly get into, but I know we are right at time for our cast today, Brian.
Yeah, but we could definitely talk in the future and schedule another one if people are interested. Maybe we could go deeper on a particular subject. I'm definitely open to that. Definitely.
And again, like, this is a very fascinating topic because it is very much, the foundation for what it means to make games. Because at the end of the day, it doesn't matter if you have the most amazing idea in your head if you have no idea how to put that to code or do anything more with it.
Yeah, I guess another point worth making is if someone is really passionate about getting into game design, another really great place to start is just at the tabletop, just cards and dice and things like that. I think you could learn a lot about game design just on paper. And in some ways, I think tabletop games are more challenging to make than video games, in some ways.
And that is definitely a discussion for another time.
Yeah.
So, with that, we are going to end things for our little cast. Again, Brian, it was a pleasure hanging out with you this afternoon. And definitely, if you have free time coming up, I've been trying to find some more like regular topics. We can do either on a month-by-month or a bi-monthly basis or every other month. Let me know if you're interested in coming back on, because again, as long as there are video games out there, I'm sure there are programming-related questions people have.
Yeah, let's talk about it. I'm definitely interested.
All right. So, before you go, do you have any social media you would like to plug for people who want to follow you or Monster Train?
Yeah, so you could go to themonstertrain.com. I think the game's really cool. It's in beta right now, so you could sign up for the beta, and you'll probably get a key within a day or two. Worth checking out if you're at all interested in strategy games. And you can follow me on Twitter at Brian G. Cronin.
All right. So, with that, we're going to end things for our discussion tonight. Let us know what you think in the comments below, and if you'd like to see this as kind of like a regular series on the channel. Again, Brian, thank you for coming on, and best of luck with Monster Train, and I'm sure, again, we will be talking in the future.
I'm sure we will. Thanks a lot, Josh.
No problem. So, for everyone watching, we're going to end things here. Come back for daily discussions on game design here and on game wisdom, where is in the art and science of games. If you are a developer working on a game and you'd like to come on for a future cast, please don't hesitate to get in touch. And check out our Discord and Patreon link down below. Patreon subscribers get early access to these design talks, as well as ad-free versions of our design casts. But that's going to do it. I'll be back later tonight for our regular game stream. Have a great rest of your day, folks, and we will talk to you next time. Take care.